Welcome to Shanti-Peace for Mathematics. In this video lecture, we are going to discuss regarding the method of separation of variable. This method is also named as a product method. While applying this method of separation of variable, we make certain assumptions. Suppose that the given partial differential equation involves the n independent variables, that is x1, x2 up to xn, and 1 is a dependent variable u. The u is depends on x1, x2 up to xn. That is a given situation, and we first assume that the equation having a solution is of the form u of x1, x2 up to xn is equal to capital X1 of x1, capital X2 of x2 up to so on capital Xn of xn, where this xi's, capital Xi's, are a functions of small xi. On substituting this value of u into the given partial differential equation, we shall obtain an ordinary differential equation with the unknowns of each of these ordinary differential equations are x1, x2 and xn, capital X1, x2 to xn. And then we need to solve this an ordinary differential equation and will obtain the value of capital X1, capital X2 and capital Xn. And we'll substitute that value of capital X1, X2 and Xn in this will achieve our solution. So let us solve certain examples based on this separation of variable. The main motivation for this to establish a solution for a wave equation, Laplace equation and the heat equation, that will discussing in my next video. So here it is, we'll just learning about what is the method of separation of variable, and using the method of separation of variable we'll able to solve certain boundary value problems. So let us consider one boundary value problems as del u by del x is equal to 4 times del u by del y. Boundary condition is given means x is 0, then it is gives the value is 8 into 3 e power 3 minus 3y. So this is the situation we have given. We can see that u is a function of x and y, and with this boundary condition it is there. So as I have discussed that to solve this boundary value problem, we need to assume our solution is, so suppose that the solution of given boundary value problem that I am writing in the short, that is BVP, is of the form u of xy is equal to capital X of x into capital Y of y, where this capital X and capital Y are the function of small x and small y. And we'll substitute this value of capital X and capital Y into this partial differential equation. So for that I need to find out what is del u by del x. Del u by del x is equal to x dash y, because a derivative of u with respect to x and y is independent of x, so that's why it is x dash y. This x dash represents the total derivative, and del u by del y is equal to x y dash. Now putting this value in given PD, that is a partial differential equation, we get x dash y is equal to 4 times x y dash, because we have the given differential equation is del u by del x is equal to 4 times del u by del y. So we have just substituted del u by del x, that is x dash y, and the substituted del u by del y, that is x y dash. So we have this. Now dividing both sides by x y, we get x dash upon x is equal to 4 times y dash upon y. We'll assume this is equal to some constant k. Let us say this is some constant is there. So therefore we can have is x dash upon x is equal to k, and 4 times y dash upon y is equal to k. So therefore we can have x dash minus kx is equal to 0, and 4 times y dash minus ky equal to 0. Now this is the two ordinary differential equation we have. The first ordinary differential equation, it is in terms of capital X, this is in terms of y. So that's why we can have this, we can write down this dx by dx is equal to k into x. Using the separation of variable method, we can write down this is capital dx upon x is equal to k times dx. So when integrate both sides, we'll have it is ln of x is equal to k into x plus some constant c. So that's why I can say that this is x is equal to e power kx plus some constant, and that e power c, I just say it is capital A e power kx, where this capital A is e power c. Now here we'll just, this is we can write down as y dy by dx is equal to k times y, and 4 is already there, and if I can, using the separable variable method as we did here, that is dy upon y is equal to 1 by 4 k dy. Taking the integration both sides, will have it as ln y is equal to 1 by 4 times ky plus some constant, let's say it is d. So therefore it is y equal to b into e power 1 by 4 ky, where this b is equal to e power d, where this b is and a are constant. And putting this value of x and y into the value of u, that is u equal to x into y, we will substitute that value into that. So therefore the u of xy, we can have it is capital X into capital Y, which will gives you a into e power kx into b into e power 1 by 4 ky. So that is the things we can get, and this will say it is c into e power kx plus 1 by 4 ky, where c is equal to a into b, that is another constant we can have. Now boundary conditions as we have given, so that's why we have given that u of 0y is equal to 8 into e power minus 3y. This is we have given. So if I substitute x is equal to 0 into this expression, putting x is equal to 0 in u of xy, we get u of 0y equal to c times e power. If I put x is 0, that is 1 by 4 ky, and u 0y we have given it is 8 e power minus 3y, so that's why it is 8 into e power minus 3y. So if I compare this one, we'll get c is equal to 8 and 1 by 4 k is equal to minus 3. So that's why the value of c is 8 and the value of k is equal to minus 12. If I substitute this value of k here, then the solution of the given boundary value problem is u of xy is equal to, the value of c is, we can have 8 into e power, k is common out, so it is minus 12 is common, x plus 1 by 4y. That can be simplified as e power minus 12x minus 3y. This is the solution for the given problem. Now let us solve another problem. The question is to solve by the method of separation of variable del square z upon del x square minus 2 times del z by del x plus del z by del y equal to 0. So here the problem is to discuss the solution for this one. There is no condition is given as a boundary condition or such things is there. But from the given solution, we can just see that z is a dependent variable which depends on x and y. So as per the separation of variable method, we need to assume that our solution z of xy, it is of this form, that is capital X of small x and capital Y of small y. And we'll need to substitute this value of z into this equation. So therefore I need to calculate what will be the double derivative of this z with respect to x. Del z by del x I need to calculate, and del z by del y. So now del z by del x will gives me x dash y. Del z by del y will gives me x y dash, and del square z by del x square is equal to x double dash y. So therefore if you substitute this value into the given equation, that is 1, if I can say this is equation 1, putting this value in 1, we get x double dash y minus 2 times x dash y plus x y dash is equal to 0. Now dividing this equation with dividing by xy, we get, that means this quantity is divided by xy, the x is left, so that's why we can have, it is x double dash upon x minus 2 times x dash upon x plus y dash upon y equal to 0. So this I can rewrite as x double dash upon x minus 2 times x dash upon x is equal to minus y dash upon y. Let us say this is equal to k. So therefore this will gives me two ordinary differential equation, which is of the form x double dash minus 2x dash upon x is equal to k, and the another equation is y dash upon y is equal to minus k. So this will simplify as x double dash minus 2x dash minus kx is equal to 0, and this will simplify as y dash plus ky equal to 0. And we can see that what will be the solution for this, that is an ordinary differential equation we have, and we know that how to solve the ordinary differential equation. So we need to write down the auxiliary equation for both this equation. This equation can be solved using the method of separation of variable. This is the second order ordinary differential equation. For that we need to have write down the auxiliary equation. The auxiliary equation is m square minus 2m minus k equal to 0. So that will gives me m equal to, that is by method of ax square plus bx plus c. This is a quadratic polynomial. So that's why it is gives me 2 minus b, but minus b is minus 2. So that's why it is 2 plus or minus b square. B square is minus 2, so that's why it is 4 minus 4 AC. A is 1, C is minus k, so that's why it is plus k upon 2a. So a is 1, so that's why it will have 2. So if you simplify this will gives me 1 plus or minus square root of 1 plus k. So the solution of, if I can say this equation is 2 and this equation is 3, therefore the solution of equation 2 is x of x is equal to a into, so this is a real roots, because if k is a real number then k plus 1, if it is a positive number then we have, this is the solution, we'll assume that k is positive here. Otherwise you will have three different cases where k is positive and k is negative. So the solution will be e power, because there are two solutions, m1 and m2, 1 plus square root of 1 plus k x plus b times e power 1 minus square root of 1 plus k into x. This will be the solution for the equation number 2. For 3, that is equation 3, we can write down at y dash upon y is equal to minus k. So that's why it is dy by y by method of separation k into dy. So we can say that this is ln y is equal to minus ky plus some constant, let's say it is c. So that's why y is equal to d into e power minus ky. So where this d is e power c we can have. Therefore we have the value of x and we have the value of y. Therefore the given solution for the given PD is z of xy is the a into e power 1 plus square root of 1 plus k into x plus b times e power 1 minus square root of 1 plus k into x, and all this quantity is multiplied with e power minus ky into c. And this a into c, I'll just say it is another variable d e power 1 plus square root of 1 plus k x plus some another variable d, that is bc, is e power 1 minus square root of 1 plus k x into e power minus ky. So this is our answer. So this is the method of separation of variable. I will give some of the example is for your practice. You can try to solve these problems by your own. That is 3 into du by dx plus 2 into du by dy is equal to 0, where the boundary condition is u of x0 is 4 times e power minus x. And you can solve this equation also, that is del u by del x is equal to u plus 2 times del u by del t, with the given condition is u of x0 is equal to e power minus 3x into 6. So this is a problem number 1 and problem 2. You can try these problems by your own. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in next video. Till then, bye bye. Sayonara.